Alright guys, good afternoon. This video is going to be basically just going over the basics of how to do a moment. Y'all started this in the late part of chapter 3, but mainly it hits you hard in chapter 4. So the easiest way to kind of describe how a moment works is, I'm sure Jackson's probably even told you this, but a moment is practically torque. So that means that wherever your spot is that you're looking at, say for example what he did is a bolt and a wrench. So your bolt is the point that you're turning, and wherever you place your hand on the wrench and you start to pull or push on it, that's going to create a torque, which is going to be a spinning motion. So to see that in a 2D spectrum from an engineering problem, it would be like a beam. So the problem that I have right in front of the screen right now is a basic beam of a distance of a total of, I believe, is 24 meters that has three forces acting on it. It's got a pin joint at A and I believe, a roller at B. So the way you do a moment, here I'm going to zoom this back in a little bit. A moment is equal to any force times its perpendicular distance. That an upside down T equals, it stands for perpendicular. I probably misspelled that, but I'm not too worried about it. It's perpendicular. So that being said, we need to find the reactions at A and B. So the first thing you do is going to just take your sum of forces in the x. We have AX is equal to 0. Nothing else is there. Take the sum of forces in the y equal to 0. We get AY plus BY minus F1 minus F2 plus F3 is equal to 0. Now the reason why I'm doing that, just to recall from beginning portions of the class, I'm doing it in basic x and y coordinate plane. But if you simplify this sum of forces in the y equation down, we get AY plus BY is equal to, I'm going to do a little quick deal on math because I've got the problem stated up here. We get 200, 600, is equal to 350 newtons. So just kind of show you it, 200 newtons minus 600 newtons. What did I say that one was? 350 newtons? I might have done some of my math wrong. Just in case, I'll double check. Yep, I did. That is a positive 450 newtons. My apologies. Okay. So, we have two unknowns. The only way the next thing to do to solve this is take a sum of the moments. Now, when you take a sum of moments, state that your positive direction is going to be counterclockwise. That's usually the basis for any engineering problem that you're going to do, statics-wise or mechanics-wise. Counterclockwise, we usually state as positive. Now, when you take a moment, you're going to want to take it about a point that's going to get you the most amount of unknowns taken away. So in this case, at pin A, there's two unknowns. But if we take a moment about there, those two unknowns go away because that's where we're taking the moment. Our only unknown left would be B. So we're going to take a moment about A to make it easier on us. Always set equal to 0, then put your arrow. So you're going to have to do it for each point that's causing a moment. So that's force 1, force 2, force 3, and BY. So force 1 is going to be causing a negative moment times its perpendicular distance, which is going to be 6 meters. minus f2, because it's also going clockwise, times its perpendicular distance, which is going to be 13 meters. Now by is causing a positive moment because it's counterclockwise, times that total distance, which is 14 meters, and our force 3, which is causing a positive moment as well, times its total distance, which is 24 meters. All of those distances are from point A to whatever we were at. So we plug our values in and solve for by. We will get what is that? 200 newtons times 6 meters plus 600 newtons times 13 meters minus 350 newtons times 24 meters, all over 14 meters. We get our by to equal, I'm going to double check my math because I have not actually done this problem ahead of time. I just wrote it down. Which we get by to be 42.9 newtons. And we state it in positive up direction, which we are correct from our statement. So now we have by. All we need to do now is solve for ay from our equation from the beginning of the sum of forces, which was equation 1. We get ay is equal to 450 newtons minus by. We found by just a second ago from the moment equation, so we get 450 minus by. Ay is 407.1 newtons. And I'll make sure I'll highlight that so we can see it. Okay. So this is so you can see everything. So if you're just given a basic beam with any amount of forces and different reactions or pins, rollers, fixed, whichever one you have, and your dimensions, to find your forces, you just use sum of forces in the x and the y, and you take a moment. So hopefully this kind of helps you get the basic understanding of how a moment works, at least in 2D. In 3D it's a little different, but we will go over that in the later sections. Hope you get any kind of value from this, and if you have any questions, please feel free to email me for this current semester, which is the fall of 2020. And at any point I go too fast for you, just pause the video, write it down, catch back up, and then go from there. Thanks, guys.